Good afternoon. Today I'm going to present my project titled Design and Implementation of an Enterprise Wireless Local Area Network for a Smart Office using Cisco Packet Tracer. The main objective of this project is to design a secure, scalable, and efficient wireless network for an organization. I have selected a smart office environment because it contains multiple departments with different networking requirements. Unlike a home network, an office network requires proper planning, security, bandwidth management, and wireless coverage. While designing this project, I focused on the four requirements. First thing, choosing an appropriate wireless technology. Second thing, justifying the bandwidth requirement. Third thing, reducing wireless interference. Fourth one, providing proper network security. So, coming to the wireless local area network, first let me explain what is wireless local area network. A wireless local area network is a network in which devices communicate using radio waves instead of Ethernet cables. A best example is the laptop, the phone, and the tablet, which are the common devices we use daily. These devices communicate through an access point instead of directly using network cables. The major advantages of wireless local area network are mobility, easy installation, reduced cable cost, flexibility, easy expansion, and scalability. This is why almost every modern company uses wireless local area network along with wired infrastructure. Instead of designing a home network, I selected a smart office because it contains multiple departments. The departments included in my project are reception, CEO room, HR department, finance department, employee workspace, meeting room, server room, security cabin, and cafeteria. Each department has different networking requirements. For example, the server room requires high speed wired communication, whereas the employee workspace requires wireless communication because employees use laptops and smartphones. Therefore, a smart office provides a realistic example of an enterprise wireless local area network. And coming to the overview of the topology I have built is the complete data flow is from the internet to the internet cloud and then cable modem, then coming to the router, then the core switch, followed by the multiple access points and the end devices. This architecture is commonly used in enterprise organization because it is modular, scalable, and easy to manage. Now, let us go through each topology one by one. So, first one is Internet Cloud. The first device is Internet Cloud, which represents the Internet Service Provider, commonly called the ISP. Instead of drawing the complete internet, Cisco Packet Tracer represents the external network using a cloud. The cloud is responsible for providing internet connectivity to our organization. It acts as the starting point of the entire communication process. Whenever an employee accesses any website, the request ultimately reaches the Internet cloud. The cloud itself does not process data inside our company. Instead, it represents the external Internet. The second topology is cable modem. Below the Internet cloud, I placed the cable modem. The cable modem acts as an interface between the ISP and the office network. The internet from the ISP arrives through a coaxial cable. However, routers cannot directly understand coaxial signals. Therefore, the cable modem converts the ISP signal into Ethernet cables. Without the cable modem, the router cannot communicate the ISP. The main aim to choose the coaxial cable is the internet service providers commonly deliver cable internet through coaxial cables. Therefore, the cloud and the cable modem is connected using the coaxial cable. I- If a person or if any organization chooses to connect with some other cables, the connection will not work as expected. The third topology is the Cisco 2911 router. After the cable modem, I placed a Cisco 2911 router. The router is one of the most important devices in the network. Its primary responsibility is to connect our local office network with the internet. The router performs several important functions, which includes routing, default gateway, DHCP, internet forwarding, and network management. During the configuration, I assigned the router an IP address of 192.168.10.1 using the command line interface, which can be observed when we click the router. Using the CLI space, we can type the commands and configure the uh, IP address. So, followed by that, the router acts as the default gateway for every device in the office. Whenever an employee wants to access the internet, the request first reaches the router. The router then forwards the request to the cable modem and finally to the internet. Therefore, the router acts as the bridge between the internal office network and the external internet. Obviously, coming to the configuration part, the router configuration is done using the CLI uh, method, the command line interface, where we use the enable command and we will configure the terminal. Then we will give the interface to select the commands which will be connected to the core switch, and obviously the IP address. Finally, the no shutdown command activates the interface. Initially, the interface showed a red indicator because Cisco routers keep interfaces administratively down by default. After executing no shutdown, the interface became active and the red indicator changed to green. This is how the indication of the particular arrow marks works. The next topology is Cisco 2960 core switch. I added a core switch which is after the main router. Instead of connecting every department directly to the router, every department is connected through the core switch, which provides better organization, easy management, scalability, reduced cable complexity. If the organization expands in the future, additional departments can easily be connected to the core switch without changing the existing network. This is a very common part, but the important concept is a router is responsible for connecting different networks. A switch is responsible for connecting multiple devices within the same network. If every device were connected directly to the router would require many Ethernet ports and network management would become difficult. Instead, we use the router followed by the core switch and the departments, which can be represented as the standard enterprise architecture. The core switch distributes the network to every department, and the connection between router and core switch will be done using the straight cable, which will be located in the connections part. In the connection component, we use this copper straight through cable to connect the router and the core switch. So this is how the main parts of the topology or network is being built. Coming to the end devices, we I mean I particularly kept end devices as for each department there will be two or three end devices, because the main aim is to demonstrate how the network is being established when it comes to an enterprise wireless local area network. So for each department I have placed around two or three end devices, and these are particularly connected to each access points, because when we don't assign the uh, unique SSID to each access point, the end devices may connect to connected to the different access points, so that it put the particular device, end device, which should be connected to a particular access point would not be able to connect it. So we use the unique SSID to match the access point and the edge devices. So basically, this is the topology, and for building this topology, there are components which will be available in this section, so that we can choose whichever we want. The network devices is the first one, and then coming to the end devices, and then the components, and for connections, the different types of cables will be available here, followed by the miscellaneous one and the multi-user connection. These will be the main segments of the Cisco Packet Tracer project. And coming to the connections, the each end device connections. So the SSID stands for Service Set Identifier, and SSID is simply the name of a wireless network. Whenever we search for Wi Fi or our mobile phone, we see names like office Wi Fi, home Wi Fi, college Wi Fi. These names are actually SSIDs. Similarly, every access point in my project broadcasts its own SSID. We can view it like this. When I click the access point of a department, when I go to the config bar, and when I click the port one, you can see here the SSID is Finance Wi-Fi. And also we use the authentication method called WPA2 PSK, and the passwords will be assigned here. So the encryption technique will be AES. So we have seen the SSID here as Finance Wi-Fi. When we inquire about its own devices, when I click the PC and if I check the wireless part, and also here we will be having the same SSID as Finance Wi-Fi, because to ensure the connection between the department will be same. I mean the same devices will be connected. So for example, this is Finance PC. When I just click the laptop of HR department, if I go to config and if I search for wireless, then here it is the SSID is different, right? Because in the previous one we have seen about the SSID as Finance Wi-Fi, but here it is HR Wi-Fi, which clearly demonstrates that unique SSID makes or ensures that the connection is secured and reliable. That is how the SSID works. And also, when we think about the connection, if we go to desktop and if we go to PC wireless, here is where we connect about the laptop or smartphones, everything wirelessly. When we just click the connect segments here, each and every SSIDs will be available, so that if we just click any of one and if we click connect, it will be getting connected. So that is how the connection works. This is how we connect in the Cisco Packet Tracer, and that is the main concepts so far. Yeah, thank you.